In our lesson video today, we're going to be jumping into day 7.2, and we're going to be talking about surface area of prisms and cylinders. So this is some new information here. But the first new thing we're going to talk about is surface area. All right. Surface area is used to find the area of all the surfaces on a three-dimensional figure. So this is our first lesson where we're starting to talk about 3D figures. We have a lot of different 3D figures we're going to talk about, three-dimensional. They exist with a length, width, and height dimension to them. All right. And the surface area in general, though, is just the sum of all the areas on the surface, the outside of the object. Okay, the sum. All right, let me get my pen going where I can write. Okay, remember, sum means to add them all up. All right, so the first 3D object we're going to look at is called a prism. A prism is a solid with two bases that are congruent and parallel. Now, this is an example of what we would call a triangular prism. Because the bases are these two triangles, these two congruent parallel polygons or shapes. Okay? So we've got one on top, one on bottom, and one on top. All right. So from this example, we kind of get the idea that the base shape determines the name or classification of the prism. So I want you to write that down. The base shape determines the name, or rather classification, of the prism. Okay, so if the bases are both rectangles, we call it a rectangular prism. If the bases are both octagons, we call that an octagonal or octagonal prism. Okay, so the surface area of prisms can be found by just totaling the area of all sides by adding them up. Okay, so find the area of each individual side and add them up. Now, sometimes we can take some shortcuts because the area of the base, or rather the bases, are congruent shapes. The area total for that is just 2 times the area of one of the bases because they're congruent. So we can kind of take some shortcuts here and there. All right, now if the bases of a prism are in fact circles, then we don't really call that a circular prism. We call that a cylinder. It has a special name, okay? And a cylinder has a special surface area formula that we're going to get to. I'm going to tell you what it is first, and then I'm going to kind of explain where that comes from. All right, so I'm going to write what the surface area of a prism is. Or, I'm sorry, of a cylinder. My bad. So the surface area of any cylinder is equal to 2 pi r squared plus 2 pi r h. All right, now I'll explain where these pieces come from. The first piece we want to look at is the 2 pi r squared. Well, pi r squared is because there are 2 circles on the top and bottom. So pi r squared is the area of one circle. So pi r squared plus another pi r squared is 2 pi r squared. Then this other portion, however, okay, 2 pi r h, that part comes from something else. And I want to kind of pause here, and I'm going to show you a demonstration. Okay, so if we look here, I have a cylinder. And actually, I have a cylinder that I've removed the circular bases. Okay, so I'm not talking about that. Okay, the 2 pi r squared that we talked about in the video covers the circular bases. So the rest of the surface area is this curved surface around the outside of the cylinder. Okay, and so if I were to take that, let me get some scissors. So if I were to take this circular or this rounded flat surface and open it up, get a rectangle. Now, when that was a rectangle has an area of length times width, right? Well, the width of this rectangle is actually the height of the cylinder. When it was all together, whenever I had it taped together, okay, this dimension is the height of the cylinder, all right? Help you see this. Okay, so width equals height. All right, now this dimension, the length of the rectangle, remember, and this was wrapped around together, was basically the outside edge of that circle. Well, the outside edge of a circle, the length around a circle one time, is another measurement we know. It's the circumference of the circle. So the length measurement of this rectangle is the circumference of a circle. Remember, circumference is equal to 2 pi r. Okay? So since the circumference is equal to 2 pi r, and that's the same as the length of this rectangle, and the width of the rectangle, sorry, over here, is the height. When I do length times width, it becomes 2 pi r times h. Okay. So when we look at our example here, the area of a rectangle part, and I kind of put it in the wrong order, is 2 pi r, the circumference of the circle, times the height, plus 2 times the base areas, the area of both circles, pi r squared. So this part is the first part of that formula, and this part is the second part. So I took a little extra time there to explain that, but I feel it's important you understand where that formula comes from. Otherwise, we need to remember the surface area of any cylinder is 2 pi r squared plus 2 pi r h. All right, so the first thing I want us to do is just get in the habit of classifying some of these prisms or cylinders. If it's a cylinder, all we have to do is say that it's a cylinder. In this first example, we have a box shape, okay? Remember, a box shape is really a prism, and it has 2 rectangles for the bases. Okay, I can think of the top and bottom as the bases, or the left and the right as the bases, or the front and the back as the bases. Because, remember, the bases of a prism are 2 congruent parallel sides. So this would be a rectangular prism. Because the bases, because the bases are all rectangles. In fact, all the sides are rectangles. Okay, this one is very easy to see. There's a circle on each side connected by this kind of curved surface here. Okay, on both sides, that is a cylinder. Sorry, I can't spell today. Let me fix that. Okay. This is another box shape, but we have these 2 surfaces here. Okay. These 2 bases that are parallel and exactly the same shape as each other, those are trapezoids. So this would be considered a trapezoidal prism. And then finally, we have another box shape. That's a prism. The bases here, the non-rectangular sides, have to be the bases. That's another way to look at this. If you have 2 sides across from each other that are not rectangles, those have to be the bases. Okay, so these bases each have 5 sides. 5-sided polygon is a pentagon. So we would call this a pentagonal prism. Okay. All right, so now let's actually identify how to find surface area. Okay, and really you can think of this as an example. Let's say I wanted to paint the outside of this shape. What are all the surfaces I would paint? Well, anything you could touch is a surface you could paint. So we can imagine picking this object up, this wedge-shaped object, and turning it around, moving it around however we want. But we should recognize the non-rectangular sides are these triangles. So those are your bases. Okay. You have one at the front and one at the back. Okay. Those 2 triangles are your bases. So we have 2 triangles to get our total area. And then we have these 3 rectangles along each side. Okay, so we're just going to do the area of the triangle times 2, and then the individual areas of each rectangle. Since they're not exactly the same size, I can't just do the area of a rectangle times 3. These are 3 separate unique rectangles. Okay, so let's do the triangles first. Remember, area of a triangle is base times height, divided by 2. Well, I really want to focus on this triangle at the back because that's where most of my information is. Okay, you can see this perpendicular segment here is your height of the triangle, and this bottom edge would be the same as this edge, 12. So your base is 12. So 12 times the height of 4.1 divided by 2, okay, gives me the area of a triangle. All right, and when I do that, 12 times 4.1 divided by 2, I get a base area of 24.6, but there are 2 of those, okay? So I'm going to double that because there are 2 triangles. All right, and now I'm going to add in the extra rectangles. So one rectangle that we have here along the bottom is a length of 12 and then a width of this measurement, which is the same as this one and this one. I'm going to clean up my picture a little bit to make it easier to see. Okay, so like I said, the bottom rectangle has a length and a width. Okay, that width is the same as all of these segments, which would be 3 kilometers. Okay, so that's a length of 12 times a width of 3. Okay, we're going to add in another rectangle. Okay, think of it as this rectangle, maybe on this right side. That has a length of 10 and a width of 3. So we're going to do 10 times 3 for that one. I'll even put these in parentheses just to kind of group them together. And then we've got one more rectangle to look at. And that's this rectangle along this kind of back left side. And that has a length of 5 and a width of 3. So we've got another 5 times 3. And so I'm just going to start adding these up. Now, if I take my 2 triangles and double that 24.6, I get 49.2. Then 12 times 3 is 36. And 10 times 3 is 30. And 5 times 3 is 15. So those are the individual areas. I'm just going to add those up. And when I plug those in the calculator and I add all of these up, my total surface area, SA for surface area, is 130.2. My unit of measure would be square kilometers. Okay? Let's try another one. These will get a little more simple as we go. For this one, okay, it's kind of tough to see. Those dotted lines kind of show you the depth of this. It's moving back in. So like the top of your prism is this. Okay, everything today is going to either be a cylinder or a prism of some kind. This is a prism. The 2 bases are actually these 2 trapezoids. This would be a trapezoidal prism. So my area has 2 trapezoids, and then we have 4 connecting rectangles. Okay, we have these 4 rectangles here on the left side, the top side, the right side slanted like that, and then this bottom one is also a rectangle. Okay? So we're going to add in 4 rectangles, but each of those is going to be different. So let's talk about our trapezoids first. Remember, the area formula of a trapezoid is 1/2 the height of the trapezoid times the sum of the bases. Okay? So the height of your trapezoid, remember, is perpendicular to both bases. So if this is base 1, which is also 18, and this is base 2, 23, the height is 12. So that's 1/2 times 12 times base 1, 18, plus base 2, 23. Let's go ahead and kind of simplify that down. When I multiply all that out, 23 plus 18 first, then times 12, then divide by 2. When I simplify all of this, I get 246. So the area of that one trapezoid is 246. But I have 2 of them, so I'm going to double that. 2 times 246 takes care of the front and the back of this prism. But now I need to add in the 4 separate rectangle shapes. Again, I'll kind of clean up my work as I go. Okay, one rectangle we have, let's just start at the top, is this top rectangle, which would have a length of 18. And this width here would be the same as this width down here, 15. So I'm going to add in a 18 times 15 for that rectangle, plus got some other rectangles here. Let's move down the right side. This slanted rectangle here has a length of 20 and a width of 15. So length times width is 20 times 15. Then we've got this bottom rectangle, which has a length of 23 and a width of 15. And then we have one more rectangle, and that's over here on the side, okay, which has a length of 12 and a width of 15 again. So 12 times 15, there's an extra one. So I'm going to add all those in together. I'm going to simplify this. I'm going to do 246 times 2 first. That takes care of both trapezoids. So both trapezoids areas add up to 492. And our first rectangle we have is 18 times 15. Okay, 18 by 15. That one is 270. Then the 20 times 15 gives us 300. And the 23 times 15 gives us 345. And then finally, the last one, 12 times 15 is 180. Okay, so when I add all of those together, I get a grand total surface area of 1,587 square feet. All right, let's try one more. All right, this is our first cylinder. For cylinders, okay, cylinders have a special, unique surface area problem because that curved surface, remember, is a rectangle. So we really can break this down and memorize this specific surface area formula. 2 pi r squared plus 2 pi r h. Okay? The height, that h, is always the distance between the circles. Okay, so this is h. Doesn't matter if it's laying, standing upright where the circles are on top and bottom, or if it's laying down where the circles are like at the front and back or left and right. The height is the distance from one circle to the other. Okay, so that's h. They give you the radius of 11 yards, so really this is just a matter of plugging things in. So I'm going to do 2 pi times that radius of 11 squared plus 2 pi times the radius of 11 times the height of 26. And then I start to simplify. And what I'm going to do is I'm going to simplify everything except times pi. Because both of these are in terms of pi, I can combine like terms in a minute. So when I do 11 squared, that's 121. And then I'm going to do times 2 here. 121 times 2 is 242. So the area of both circles add up to 242 times pi. Okay, and then I'm going to simplify everything over here. When I do 2 times 11 times 26, 2 times 11 times 26, that gives me a total of 572, and it's still times pi. But now these are like terms, so I'm going to add 242 and 572. In my calculator or on paper or in my head, I can add those, and I get 814, but then I still have to multiply by pi at the end. Okay, all we really did was combine these as like terms. Okay, so then I do 814 times pi, and I get a pretty big number, but that's okay. I get 2,557.3 square yards. Now, if you're getting things a little bit differently because maybe you got these as decimals first and then added those, that's okay. You should be getting pretty close to what I get. All right, let's go ahead and turn the page and take a look at just a couple more examples. At the end of the last lesson, we talked about composite figures. Well, that applies to three-dimensional shapes as well. So we have the idea of composite shapes is the idea that we can just add their individual components to get a total surface area. Now, the trick with this one is when I stick these together, there are certain surfaces that are no longer a part of what I include in my surface area. Anything that's covered up, like if I wanted to coat this in paint, I wouldn't paint this rectangle here because it's covered up between the two figures. So we have the idea that we need to either subtract those surfaces later, or it's often easier, like I said, we can subtract. However, sometimes it's easier to just exclude, meaning don't use. Okay, exclude means do not use those. Don't add those in. Okay? So when it says what faces will not be included, that means excluded. Which faces or surfaces will not be used. And so that would just be, in this case, the rectangle, which has dimensions, I'll give it by its dimensions, that's easier, 17 by 13. That is between both prisms. Okay? So that's the one I'm not going to use. But I can add in all of the other figures. So we're going to kind of take this from the top down. We're going to start off, we've got two trapezoids. Okay, these two trapezoids, front and back here. So that top part is a trapezoidal prism. Okay, plus we have the three rectangles that are on either side. We don't have this rectangle, remember. So we only have three rectangles. We have the 13 by 15 rectangle on the right. We have the 6 by 13 rectangle, because all these are 13s, on top. And then we have another 15 by rectangle. They mark these segments congruent, so we know this side's also 15. So we have another 13 by 15 rectangle there. Okay? So we're going to add those in. These first two here take care of that top figure. But then we also have rectangles along the bottom. We have all these extra rectangles. There's actually a front and a back, 1, 2, a left and a right, 3, 4, and a bottom, 5. So there's another 5 rectangles on the bottom. Okay, so this kind of plans out what I'm going to do for this example. Okay, so let's talk about the trapezoids first. Remember, the area of a trapezoid is 1/2 times the height times base 1 plus base 2 in parentheses. So let's figure out the height of your trapezoid. The height of the trapezoid is from here up to there. That's how tall the trapezoid would be. Okay? Well, they don't give you that. However, we can take this total height of the figure, 22, and subtract this length, which is not 13, I'm sorry, I underlined the wrong one, which is 8, because all of these segments are 8. So if I do 22 minus 8, I get 14 as the height of my trapezoid. Okay? So I'm going to do, for the area of a trapezoid, 1/2 times 14 for the height. Base 1 of the trapezoid is this, it's also 6. Base 2 of the trapezoid, sorry, I'm kind of zooming in all over the place. That's my base 2, which is also 17. And then I could simplify that. Okay, as I start to simplify that, okay, when I do 17 plus 6 times 14, and then divide by 2, I get the total area of one trapezoid is 161. So I need to do 2 times that area because there's 2 trapezoids in this figure. And then I can start to add in the other pieces. So let's look at the rectangles from that trapezoidal prism, the rectangles on top. And again, as I go, I'll kind of clean up my work to try and make this easier to see, because it's easy for me to quickly erase all that. Okay? So now we want to start with these different rectangles. So we've got one rectangle that's kind of skinny and narrow on top, and that one's easy enough to do. That one is 6 times 13. So I've got a 6 times 13 rectangle. Okay, then these other two are identical to each other. The left and right sides up here at the top are each 15 by 13s, okay, on that side and this side. So I've got 2 of the same one, so I'm going to kind of just double that up. I've got 2 rectangles that have dimensions of 15 and 13. So that takes care of the entire top portion. That takes care of those. Length times width, remember, is how I'm finding each of those. Then I've got these 5 separate rectangles on the bottom, but I do have some that pair up. Okay, the front and back of these, okay, like the front and back are congruent rectangles. They're each 17 by 8. So I've got 2 of those. Okay, so I've got plus 2 rectangles that are 17 by 8. Okay, that's the front and back. The left and right rectangles, another two, are identical to each other. They're each 13 by 8, or 8 by 13s. So there's two of those. And the only thing left is the bottom rectangle. Okay, this bottom rectangle is 17 by 13. So we have one of the 17s by 13s. We don't include both of them, top and bottom, because one of them is covered up. So we have just a single 17 times 13. So there's a lot of little pieces we can work with and add together now. So I'm going to start combining things. So when I do my two trapezoids, 2 times 161, I get 322. Okay. Whenever I do my 6 times 13, that's 78 from the very top one. But then I have two of the 15 by 13s. When I do 15 times 13 and double that, I get 390. Okay? I'm going to add those to these other ones that I've kind of color-coded in red. When I do 2 times 17 times 18, that is 272. That's that one. Okay? And when I do 2 times 13 times 8, I get 208. Okay, that's that one. And then finally, 17 times 13, the very bottom rectangle there is 221. So 221. So I'm going to add all of these pieces, these 6 pieces. I'm going to add those up. Okay, for the top ones, whenever I add just those ones in blue there, the top 322 plus 78 plus 390, I get 790. Whenever I add in the ones from the bottom figure, 272 plus 208 plus 221, I get 701. So when I add those all together, I get a final surface area of everything combined. It's 1,491 square centimeters. Okay, so these do take a little bit more work. Okay, got one final example I want to show you here, and this one is a little more simple in some ways. It's also a little more complex in other ways. Okay, because I've stacked 2 cylinders here this time, I'm going to be using my cylinder surface area formula. Okay, surface area of a cylinder is 2 pi r squared plus 2 pi r h. I'm going to do that, but there is a portion that is excluded here. The surface that's not included is the little circle. Okay, and it's actually not included twice. All right, because it's not included as part of the little cylinder, we also need to subtract it from the big cylinder. It's like a hole cut out of the big cylinder. So this is kind of tricky, and this is, I think, the best way I can explain this. We're going to do a big cylinder plus the little cylinder, then we're going to minus 2 little circles. Okay, we're going to cut those out and get rid of them. Okay, that's where this is important. So we're going to do the big cylinder, that bigger flat one at the bottom, plus the one littler one from the top, and then I'm just going to subtract those 2 cylinders at the end. Or sorry, not 2 cylinders, 2 circles at the end. Remember, that's just 2 of those pi r squareds. So here's what we're going to do. The big cylinder, we're going to use the radius of the big cylinder, which is half of this 38. Okay, 38 divided by 2 equals 19. So when I use my formula here for my big cylinder, I'm going to do 2 pi times the radius 19 squared plus 2 pi times the radius 19 times the height, the distance between them, is 14. Okay, that's all going to give me my big cylinder. Then I'm going to do my little cylinder. For that, I need to find that radius because they don't exactly give it to me. Okay, I got to figure that out. However, I know these centers are exactly lined up. So I know the distance from the center out to the far edge here is a radius of 19. But this length from where this little cylinder stops to the edge of the big one is 13. So I'm going to take 13 away from 19. I'm going to do 19 minus 13, and I'm going to get 6. Okay, so the radius of this little cylinder is 6. So for the little cylinder, I'm going to do 2 pi times the radius. Okay, I'm using this here. 2 pi times that radius of 6 squared plus 2 pi times the radius of 6 times the height of that little cylinder. And again, I've got to do some work here to find that. That height is my total height, 23, minus this height, 14. Okay, when I do 23 minus 14, I get that height is 9. Okay, so that finishes that formula for the little cylinder. And then don't forget, we actually want to subtract 2 little circles. Okay, the little circle is a little pi r squared, so that's the radius 6 again. So we're going to do minus 2 pi times 6 squared. Now there's a couple ways we can do this. What I want you to notice here is this. I'm subtracting 2 pi times 6 squared. I have this part that's 2 pi times 6 squared. So what I could do is just not do those. They cancel each other out. So really, I'm going to do this portion plus what's left of that portion. Okay, the easiest thing to do is to write it out in long terms like this, and then notice that these 2 terms here that I've circled cancel each other out. So that makes this a whole lot easier. So I just have this part and this part, and I'm going to add those up. Okay, so when I do this part here in blue, okay, for my big cylinder, I've got 2 pi times 19 squared plus 2 pi times 19 times 14. When I do 2 pi times 19 squared, that gives me 722 pi. But then I also have to add in the 2 pi times 19 times 14. So if I do the 2 times 19 times 14, I get 532 pi. Okay? All right. But then I have another term over here. Okay. 2 pi times 6 times 9. If I simplify that into everything except pi, I get 108 pi. Okay? So we're going to do that, and we're going to combine all of these, and actually I'm going to do 722 pi plus 532 pi. 722 pi plus 532 pi. That gives me about 3,939.6. 3,939.6. And then when I do 108 pi, that's about 339.3. And so when I add those together, I get a grand total of about 4,278.9 square millimeters. Okay? So there's a lot of work on some of these, but trying to break it into its individual pieces is the best way to go about doing this. All right? So if you have any more questions, make sure you either ask in class or send me a message through Canvas, and I'll try and help you out as best I can.